All right, you guys. So 9.3, what we're looking at is we're looking at measuring weight and temperature. So I think this will be pretty, well, I say that, but I think this will be pretty short and sweet. I don't think it should take us too long to do this. Same idea as 9.1 and 9.2. We're going to have some conversions and switch them around. So the idea of weight, and you probably know this maybe from like if you've ever had a physics class or anything, like if you have a weight of a person on Earth, let's say like 150 pounds on Earth, if you actually measure their weight on the moon, it would be about 25 pounds because weight is technically a measure of the gravitational pull on an object, whereas mass is the measure of the quantity of matter in an object, and that is kind of determined by molecular structure. So I want you to know we're going to use weight and mass kind of interchangeably. We're going to kind of call them the same thing in this section, but realize that, out there, if you're at a party and someone wants to start discussing weight and mass, realize that technically they're different and that your mass would be the same on the moon as it is on Earth, but your weight is different because it takes into account gravitational pull. So just kind of understand that. Okay, so a couple things. Let's just look at, let's just write these down, and then we'll just do a couple of examples, and then we'll talk about temperature, and I think that's all we're going to do about. So English system, when we're talking about weight, how heavy something is, I guess is how you kind of think of it. We know 16 ounces. So now remember we had ounces in section 9.2, but when we were talking about ounces in section 9.2, we were talking about fluid ounces. So now we just have ounces. So we say 16 ounces is 1 pound. And the abbreviation for pound, as you probably all know, is LB. Right? So that's 1 pound. And then another, there aren't a whole lot of English system there aren't a whole lot of different, I'm sorry, I got a little distracted by some noise outside of my office. 2,000 pounds is 1 ton, and that's really about all we have in the English system when it comes to weight. Okay, so 16 ounces is a pound, and 2,000 pounds is a ton. So, when this is, me now pretty well, and when someone tells me like, oh, I have a ton of homework, I'm like, really? So if you weighed all your homework, it would weigh 2,000 pounds? Oh my goodness, that's a lot of homework, right? When I know what I mean, but it's me. And so I have to be like, are you sure it's really a ton? Or I had a ton of fun. That's not possible because ton is a measurement or is a unit of measuring weight. And so that's not possible. I'm super fun. I'm super fun to be around. Okay, let's talk about the metric system. So just like we saw before when we talked about a distance, what was its unit of weight? Its unit of weight was a meter. When we talked about volume, its unit of measurement was a liter. So now when we're talking about the metric system, our unit of weight is going to be the gram. Okay, and so again, just like we had before, we would have kilogram. Okay, we would have a hectogram. Whoops. We're just going to do the abbreviations. I'm not going to write these all out. You've already written them all out in your book. We have a decagram or a dag. Of course, that one's my favorite. Then we have a gram. Then we have a decigram. We have a centigram. And of course, we have a milligram. So mostly the ones that are used are gram, milligram, and kilogram. Just kind of like with liters, you really just use kiloliters and maybe milliliters, and the rest of them you don't see as much. But again, what is the kilogram? Kilogram is 1,000 grams. This guy, right, is 100 grams. This is 10 grams. This is just 1 gram, obviously. This is 1/10 of a gram, 100th of a gram, and 1,000th of a gram. As we have come to know and love and expect of our lovely metric system, that it's just pretty straightforward, okay? So, I forgot to mention up here a ton, capital T. All right, so the other way that we can do conversions, I'm just going to kind of do all of our conversions here at once, is write out everything here. Let's do English and metric together. And then we'll just do a bunch of examples. Not a bunch. We'll do a ton of examples. I've probably used that before and not even know it. Some of our conversions from English and metric, okay, is 1 ounce is equal to 28 grams. Okay, and 1 pound, just use abbreviation here, is 0.45 kilograms. Okay, so those are all the conversions that we're going to kind of need to do weight. And if you look, you can look in your chart that I gave you, the weight there, I give you the English system, so I give you these two, and then I give you these two. And then this stuff right here is just going to be used for your you're going to use it when you have the King Henry thing. King Henry died Monday drinking chocolate milk or whatever. That's going to be the same thing for the grams as it was for the liters and everything else. All right, so let's do some examples. Oh, I'm on that layer. Okay, so I don't even have to clear that. Let's do a quick example. Let's just start converting stuff. There's not a whole lot to do with this one, but these are pretty fun. So what if we wanted to convert 4.2 decigrams to milligrams? So remember, let's go back to our thing here. So decigrams, so I'm right here, 2 milligrams. So I'm going this way. So we usually use our arrow on the top. So what are we going to do with those? We're going to multiply it by 10 twice. So let's do that. So multiplying by 10 twice, oh, whoops. I didn't mean to write on that guy. Multiplying by 10 twice, right, is the same thing as moving my decimal place to the right 2. So that would be 420 milligrams. So pretty easy when you need to make sure you kind of recognize what your units are. So, if you're going metric to metric, you're going to do the King Henry stuff. If you're going from English to English, you're going to use a conversion, unit fractions. Or if you're going between English and metric, then you're going to use the unit fractions there too. All right, so centigrams here to, what did I say? We're kind of putting this 2 grams. So I would move over twice, right? So that would be, that'd be divide by 100 or move your decimal to the left too. So that's 6.2 grams. Okay, pretty easy. I think it's pretty easy. Look at the fun sheet too. Have the solutions on the fun sheet. What if we wanted to do 120 pounds to kilograms? Okay, so 120 pounds to kilograms. Let me really quick. Just want to do one thing really. Oh goodness, it always gets mad at me when it doesn't know what I want it to do. What I wanted, I don't know why I'm doing all of that. I just wanted to get rid of some of this. Okay. So I don't know why I did that. I'm sorry, you guys. That's because I am still kind of sick. So 120 pounds to kilograms. If I look at my metric, oh my goodness, this is not, sorry guys. If I look at my metric to English, so 120 pounds, 2 kilograms, I know that 1 pound, wow. I'm just batting 100 here. This is 1,000? I should not be making baseball references because I don't do baseball. I know 1 pound is equal to 0.45 kilograms. Okay, so if I want to go from 120 kilograms to 120 pounds to kilograms, I have 120 pounds, right? So I'm gonna put that over 1. Then I want the pounds to go on the bottom, kilograms on top, and so I'm gonna put the 1 on the bottom and the 0.45 on top. Pretty easy peasy, I would say, don't you think? 120 times 0.45 is 54 kilograms. Okay, part D, what if I have 500 grams and I want to go to ounces? Okay, so I know I have 500 grams all over 1. I know that there are 28 grams in 1 ounce, so I want the gram to cancel out, ounces to stay. There are 28 grams in 1 ounce, so I'm going to do the 500 divided by 28. So how many ounces are we going to get? 17.86 ounces. Okay, so I hope this kind of makes sense. It should be pretty straightforward. Sometimes you might have to go do a couple steps, but I trust you can do that. Like if I was to go from grams to pounds or something, I would have to first go from grams to kilograms or grams to ounces and then ounces to pounds. But look on the fun sheet, I've done a couple kind of like that. All right, and so this is the example in 9.2 that I was kind of thinking about that I think is kind of fun. So the prescribed, whoops, and then we'll talk about temperature and then that's it. The prescribed Dosage of a drug, let's say. We don't know what the drug is. It's some drug. Okay, is 6 milligrams per kilogram, right, daily. So, you know, what does that mean? That's like for how much you weigh, right? That's how much of the drug that you get. So how many 200 milligram tablets should be given to a patient weighing 150 pounds? Okay. How many 200 milligram tablets should be given to a patient weighing 150 pounds? So first, look at what we have. I have 6 milligrams per kilogram. So what I need to do is I need to get my 150 pounds to kilograms. So my first step is to convert pounds to kilograms. Then I know for every kilogram this person weighs, they get 6 milligrams of the substance. So I have 150 pounds over 1. I want to get rid of the pounds, keep the kilograms. Okay, there are 0.45 kilograms per 1 pound. So I just multiply that 150 times 0.45 is 67.5 kilograms. So this person weighs 67.5 kilograms. Now let's figure out the dosage. Okay, so I have 67.5 kilograms. That's how much the person weighs. And then I'm going to multiply the 6 milligrams per kilogram, right? That's how much the person gets per kilogram. So for every kilogram here, that person gets 6 milligrams of whatever that drug is. So if I multiply these, this person gets 405 milligrams of the substance. Okay, and now the last thing to do is look at, we'll kind of do it over here, how many tablets then? Okay, so again, I can think about this as units. So I have 405 kilograms, or, oh, I'm sorry, excuse me, we've already, milligrams. We know this person needs 405 milligrams, right, of the substance, right? And we know that in one tablet, there is 200 milligrams. See how I used a unit fraction even with something that we weren't maybe necessarily used to using? But I know I have one tablet, there are 200 milligrams. So if we divide that, 405 divided by 2, it's 200. No, it's not. 405 divided by 200. Let's not give him 200 tablets. Please don't do that. Oh my goodness. Holy moly, I'm not a medical professional. Clearly. So we need 2.025 tablets. So how much are we going to do? Don't say 3. Don't say 3. Let's do 2 tablets, right? I hope that makes sense. That I kind of like that one because it seems like I do unit conversions a lot with my kids because when we're doing, we're taking dosages of things, if Eliza weighs 40 pounds and she gets 100 milligrams per 30 pounds, how do you do that? So it's kind of an interesting thing, a useful thing, right? That I hope you'll see will be useful someday in the future. Definitely will be useful in the next 4 weeks, before our before our final and next test. All right, let's look at temperature, and then this is the last thing we're going to talk about. So there are 2 different temperature systems also. So there's the Celsius temperature and the Fahrenheit temperature, and we do Fahrenheit. And your book does a cool little kind of story about the guy named Fahrenheit, I believe, who kind of came up with that system and kind of looked at he basically said that the temperature at which water with salt in it freezes, he said that was the freezing temperature, so that was like 0. But then he went from there basically and went to the boiling temperature and kind of broke it up into little slices. And so, for Fahrenheit, H-E-I-T. So at Fahrenheit, we know that 32 degrees Fahrenheit is freezing, which makes no sense at all, but apparently that's where it comes from when he was looking at water with salt and water without salt and when it freezes. And 212 degrees is boiling, right? 212 degrees. Yeah, water boils. And then there's Celsius. I spelled that wrong. You guys probably saw that. Celsius, which of course makes more sense because 0 degrees Celsius is freezing, makes more sense, but we are so used to using Fahrenheit that we don't really understand things. Like if I'm dealing in Fahrenheit and I know it's 5 degrees out, like I have an idea about that, but 5 degrees Celsius doesn't really mean anything to me. So we have Fahrenheit and Celsius, and basically it's pretty interesting because these were just like, they just kind of broke this up into like little pieces, into steps. So this is actually a linear relationship. So if you actually looked at the point, right, 0, 32, and the point to 100, excuse me, 212, you could put, you know how we did lines in chapter 7? You could actually find a line between these 2 points and figure out the slope of the line and the y-intercept, and that is how you're going to get the relationship between Fahrenheit and Celsius. So when you are going from Celsius to Fahrenheit, you will use the following. Okay, you will use the equation F equals 9/5 C plus 32. Look at this, it's just a line. Isn't this cool, you guys? I think it's kind of cool. That's your slope is 9/5. Your y-intercept is 0, 32. That makes sense, right? Because at 0 degrees, you have 32 degrees Fahrenheit. This is going from Celsius to Fahrenheit. Why is that true? Because you're going to be given a Celsius, so you're going to plug that in. And what is this guy going to spit out? It's going to spit out Fahrenheit. If you're going from Fahrenheit to Celsius, you will use this equation. Okay, if I just solve this equation for C, you're going to get 5/9 of F minus 32. Please use those parentheses, especially when you put it into your calculator. It's quite important that you put those parentheses into your calculator. So Fahrenheit to Celsius, again, look at I'm plugging in F and it's spitting out C. Okay, those are our equations for temperature. That is how I this is kind of another unit, right? Temperature is a unit, and this is how I'm going to convert between those two. 2 examples, and then we're done. We are out of here. So convert. So I always am interested, like, you know, we set our temperature in our house at like 66 degrees Fahrenheit. Well, actually, let's do the Celsius first. We'll get back there. Let's do, how about a negative 10 degrees Celsius to degrees Fahrenheit. Okay, so I'm going to plug in Celsius. So I'm going to take this top equation here, because if you notice, if I plug in C, which is what I know, it spits out F. So what am I going to get here? I'm going to get F then equals 9/5 times negative 10, okay, plus 32. And you can just put this into your calculator. You can do 9 divided by 5 times a negative 10, making sure you use the negative key and not the subtraction key, plus 32, and we get 14 degrees Fahrenheit. Okay, so a negative 10 degrees Celsius is about 14 degrees Fahrenheit. Back to what I was thinking, if I have 66 degrees Fahrenheit, that's like in my house at night. Probably not during the day, I'm not that mean. I want to go from Fahrenheit to Celsius, so I'm going to, Celsius then is 5/9. Right? And I'm going to go ahead and put in that 66 here, 66 minus 32. And I can again do 5 divided by 9 times, but you have to put a parenthesis, 66 minus 32, or do the 66 minus 32. And so what is that in Celsius in my house? It's about 18.89 degrees Celsius. I'm going to start doing that to my husband. I'm going to be like, listen, can we set it at like 19 degrees Celsius tonight? Because I'm cold. Because I'm cold every night. Guys, that's it. Isn't that great? So I hope that kind of makes sense. If you have any questions, again, I might be slow to answer on email, but please still do email me. Email me any questions you have on the homework or the fun sheet. The take-home quiz is going to be due Tuesday right when we get back, and you can get all of that stuff off of Canvas. So again, holler if you have any questions. I'll miss you guys, and I will see you back on Tuesday the 20th.